Greetings, and welcome to the glorious inner workings of the Windows 10 operating system. I'm Adam Dokiatin, and today I'm going to take you on a wondrous journey into the complex web of systems and operations found in your very own computer. So here's our schedule. We'll be covering 4 absolutely wonderful topics and the way in which the Windows 10 operating system handles each one. We have CPU scheduling, physical and virtual memory management, file systems, my personal favorites, and of course, we cannot forget I/O management. Okay, so first up, we have CPU scheduling. Starting with the big question here, the biggest question of all, in fact, what scheduling algorithm does Windows 10 use? Simple. The answer is, of course, the round-robin scheduling algorithm with multi-level feedback queue for priority scheduling, or RRSAWMLFQFPS for short. So yeah, let me tell you a little bit about how it works. Simple, super easy, all right? The system assigns processes to different queues based on priority. This ranges from priority 0 being the lowest to 31, which is the highest. If not specified by the process itself, this priority may be based on CPU burst, as in processes that consume more CPU time are placed in a lower priority queue. Then, the queue with the highest priority is assigned to time slices, round-robin style. If none of the processes are ready to run, the queue with the next highest priority gets to go instead. When a process is ready to run, its threads are partitioned into multiple thread queues of, again, different priorities. Threads that wait too long in a lower priority queue may be moved to a higher one. If a queue in a higher class becomes available to run, the system stops executing the lower priority thread, that is, without allowing it to finish using its time slice, and assigns full time slices to the higher priority queue. So I hope that explanation cleared things up. Just in case it hasn't, here we have different priority classes, as well as the priority levels available to threads within each priority class. Commit them to memory. And here's an example of each priority level in the above normal priority class and its associated priority value. Well, that sure was a lot of fun. Let's talk about physical and virtual memory management next. Memory management in Windows 10 is all about these 3 things, okay? Disk paging, demand paging, and the translation look-aside buffer. So this disk paging is when the operating system extends its physical memory by reserving space on the hard disk. This is referred to as a page file. When there's not enough space in physical memory, the OS will use this page file instead. The translation look-aside buffer is basically a cache that the MMU checks for data before going to physical memory. This has the very helpful effect of increasing the speed of the system. Finally, demand paging allows processes with a combined memory demand to exceed available physical memory space. It accomplishes this by segmenting processes into smaller tasks. Only threads that need immediate processing are loaded into memory, rather than sticking the entire process in there. One thing to note though, graphics and hardware drivers have memory reserved for them and are not available to the memory manager. So I know what you're thinking. You're wondering, hey, what page replacement algorithm does Windows 10 use anyway? Well, I regret to inform you that even I don't know. Nobody really knows, except Microsoft. Since Windows products aren't open source, and Microsoft doesn't seem to be sharing this information, the algorithm in question remains but a mystery. I'm afraid. People on the internet, however, claim that it may be one of first in, first out, last in, first out, or the clock version of everyone's favorite second chance algorithm. Will we ever know the identity of the algorithm? I don't know. One day. So yeah, we may not know much about page replacement algorithms, but I can tell you exactly what file system Windows 10 uses. Let me tell you, and that file system is, that's right, the big bad NTFS, aka the new technology file system. Let me tell you a little something about NTFS. Number one, it's the most widely used file system in the world, hands down. Second, Windows has been using it since the turn of the century. Best of all, to the users, files are just organized like into regular old sorted directories. Amazing. Here's 3 more absolutely killer features about NTFS. Super important, it's reliable, as in it's a recoverable file system, as in it keeps track of transactions against the file system, so then in order to restore consistency within the file system, we need only roll back transactions to the last commit point. And then single sector failures, think of the past. How, you may ask? Well, unlike inferior file systems like FAT or HPFS, there's no special locations on disk when we're working with an NTFS. And it's failures in those special locations that cause single sector failures. So single sector failures for NTFS, forget about it. Not only that, my friends, but NTFS keeps multiple copies of the master file table. Absolutely incredible. And last but not least, NTFS, super extendable, meaning it can be added to and built upon forever. So maybe you're not convinced yet of NTFS's dominance over all other file systems, right? Well, if your volume is over 400 megabytes, I can bet you that it's the only file system you'll be using, NTFS. This is because performance doesn't degrade as the size of the volumes go up, unlike some other file systems. And yes, okay, sure. There are, a couple minor things about NTFS that, aren't so great and so hot. Namely, you shouldn't use it on volumes of less than 400 megabytes since the system files themselves can take up a decent amount of space. Ultimately, this means you can't use NTFS on a floppy disk. But on the other hand, why would you even use a floppy disk in the first place? And yeah, okay, sure. There is no file encryption. But I mean, think about it. What do you have to hide? What do you really have to hide? It's all good. It's fine. So I hope I've swayed you on the unlimited benefits of using my all-time favorite file system, NTFS. Now for our last Windows 10 topic, and then we're out of the woods, and this is an important one, I/O management. In Windows 10, an I/O manager handles all the input and output to and from peripheral devices, and it does this asynchronously. The I/O manager provides a consistent interface for kernel mode drivers, ensuring that requests to drivers are sent in the form of I/O request packets, or IRPs. The I/O manager also defines a set of standard routines, some required and others optional, that the drivers can support. This leads to a fairly consistent implementation model. Despite the differences among peripheral devices and the wide range of functionality required of bus, function, filter, and file system drivers. To the I/O manager, system hardware, drivers, and their associated devices are represented as objects, meaning the I/O manager can export kernel mode routines that drivers can call to manipulate objects. How cool is that? Well, anyway, that's it. Thanks for letting me tell you all about the Windows 10 operating system. What you do with your newfound knowledge, well, that's your responsibility. Okay, bye-bye.